Alright, so then the electron at point C will be moving 4.4 meters per second. And that sets us up for success in the last part, which is the C to D part. So I lost my D. And so let's tuck this stuff here, our energy material. Let's tuck that up, and then we'll go ahead and do the last part. Just tuck this right up in there. All right. Now, in the last part is a two-dimensional motion problem. And so let's grab a pen and we can go ahead and write v c x v d x a acceleration from C to D in the x direction, the time from C to D, and of course delta x from C to D. And we can do the same thing with the y, v c y, v d y, a y, and then delta y from C to D. There's the quantity we're looking for. This is going to be the 1.2 meters plus the 0.45 meters due from the radius of that curved path. That comes out to 1.65, and I'm going to make that negative. I'm going to call down negative and up positive. In the y direction, it's in free fall once it leaves the edge of the track, so 9.8. That's 1.65 negative. V dy is an unknown. Cy, that's how fast it's going vertically at point C, and that's 0 because it comes out horizontally. But this is that 4.4 meters per second. That's an unknown. That's 0. And this is also an unknown. So in order to find this y, we're going to need more information than we have. So let's try to find the time it takes to get from C to D, and we can do that with the displacement equation in the y direction. The reason we can do that here is we have enough information, really. So v cy times time C to D plus 1/2 acceleration y time from C to D squared, and then putting the numbers in, negative 1.65 equals 0 times t C to D plus 1/2 negative 9.8 times the time from C to D squared. And if you solve for the time from C to D, you get 0.58 seconds. Then that leaves us just one last thing to do. I'm going to tuck this away a little bit. All right, well, part of my workspace crashed, so I'm just going to finish up by doing the last piece. So we found the time from C to D was 0.58 seconds. And then next we're just going to find out the displacement. We can use the x displacement equation, plug in the velocity at point C, which is all horizontal, times the time it takes to fall, gets you a delta x from C to D of 2.56 meters. But the distance from the gun to landing, which is what is asked for, we need to add that additional radius that it goes around, and so 2.56 plus 0.45 equals 3.01 meters. That's it.